Alright, so welcome. This is our demonstration for our MIDI controller. So what a MIDI controller is it operates with the musical instrument digital interface, which is a communication protocol for musical instruments. So this is an acrylic box that houses an Arduino Mega that's attached to 16 digital inputs and 9 analog inputs. So all the analog inputs are potentiometers, and these are buttons. So what this allows us to do is control virtual instruments within a digital audio workspace. So the digital audio workspace I'm using is called LMMS. Alright, so I guess Tyler will explain to you kind of like how we designed it, and then I will do a live demonstration and show all the functionalities of our controller.
Alright, so the basic necessities of our design was just that it needed to fit all of the components that we wanted to house in it. So from the beginning we always wanted to have 16 buttons for the full octave, and then knobs, a varying amount of knobs so that we can have a bunch of different functions. So we found that a box of 1 foot in length really fit all our needs, both with the interface and be able to fit everything nicely, and fitting all the components inside with all the wiring and all that. So the design I built in a program called Fusion 360, and then we were able to purchase the 1/8" acrylic online, and used a laser cutter in the ECE lab to cut it out. And yeah, that's pretty much it. So hand it back over to Omri for a live demo.
Alright, so I will show the entire controller now, and let's see if you can barely see the LCD screen here, but what is happening is that we have coded a couple different play styles. So up in the top line, it's showing that we're in the freestyle play mode, and right now in my digital audio workspace, I don't know if you can see, but I have a piano instrument connected to the MIDI controller. So right now I can play notes, and every time I play a note, it tells me what note I'm playing and turns on the lights, as well as like when I turn a knob, all the lights change just to show the user what's going on. So everything is configured, and within this play mode I have full access to the entire 8-octave range of the piano keyboard. So I can I just went down an octave, so right now I'm in the 3rd octave. I can go down another one, and we're playing lower, and I can keep going back up all the way to 7 octaves, really high notes. So I'll bring it back down to octave 4, and now I'm going to put it in a second play mode that I coded. It's called arpeggiate. So what an arpeggio is in music, it's four notes from the root note to the top of the root note, going up and down. But this mode is an arpeggiate mode, so you can play any number of notes, and it will cycle from the bottom note to the top note, and then cycle back down. So it's asking me to. It says the ARP is on. It's asking me to tap pad 1 for the tempo, and what that does is that it activates an interrupt within the code. It takes the time. The second time I tap, it takes the difference in between those time, and it converts it to a beat per minute. So I'll demonstrate that for you. So right now I'm tapping at about twice per second. So it's gonna give about 100. Right now it's 132 BPM. And what's gonna happen is if I play a note, it will just repeat that note with a delay in between of about 500 milliseconds. So you can see that's what's happening, and if I'll play any number of notes. So it starts at the bottom, cycles up, and cycles back down at the tempo I want, and every time the note plays, it prints it on the screen, tells you it's playing, and changes the lights to let you know that the note is working. So that's about it for all of the functions. An expansion pack of this would be to make a synthesizer add-on. Computers can make any type of synthesis, ranging from like sine waves, square waves, saw waves. So time permitting, make a synthesizer circuit with audio output, and then we would be on our way to creating professional level musical equipment. Thanks for watching.